recording now, and I'll have to make a video to catch up the bits that I've missed. So I'm just going to recap really quickly. Let's just recap a few things really quickly. So we're looking at chemical analysis. Things that are really important, that you know what a pure substance is, made of one compound or element. Fixed point is the melting and boiling point, and that's how we determine if something is pure, that it melts at a fixed temperature. And you know what a formulation is. So for example, paint contains solvent, binding agent, and a pigment. Method for chromatography. Now, calculating RF values. So a component will move a different amount dependent on how soluble it is. So component 3 here is more soluble than component 1 because it moved further in this solvent. So chromatography separates things by solubility. They must be soluble or you can't separate them using chromatography. Yes, sir. Just thought there was another question there. Right. Now some easy ones. Okay. Now some easy ones. So this is a nice, easy set of things to learn how to do. Whoops, I've gone forwards. Okay, which is testing for gases. You have to know these tests. So quite a lot of these you've probably done before. So the hydrogen test, you get a tube full of hydrogen, you put the splint to it, and it does that. We call it the pop test. Okay, it's not the lighted splint test or the glowing splint test or anything. It's called the pop test. That's actually its name because it makes a popping sound. Oxygen, you blow the splint out so that it's still glowing red hot and you stick it in. If it's oxygen, it catches fire again. Okay, it bursts back into flame. Chlorine, well, chlorine's actually quite easy because often you can smell it. It smells like swimming pools, that characteristic sharp smell. But also, if you get damp blue litmus paper, it goes red and then white. It gets bleached in chlorine. But the paper has to be damp. If it's not wet, it doesn't work. And carbon dioxide, we bubble the gas through it. If the lime water goes cloudy, looks like milk, it was carbon dioxide. And you've probably done, I would have thought, 2 or 3 of those tests previously. Okay, so there's those in a little bit more detail so that you can see the equipment. So you've got a delivery tube bubbling it through there, and the chlorine, it sometimes goes pinky red first, but eventually it goes white in chlorine because it gets bleached in entirety. Okay, so let's just check that you were actually awake and paying attention during this. So stop sharing that one. What number do I want? Oh, okay, let's just go back a couple of things and see if people were awake. So what was the test for an alkene? What did we put in to test for an alkene? Good. People were awake and also haven't all got up and gone to make a cup of tea. Excellent. I'm going to stop it there. Coming up to everyone having voted. And the vast majority of you remember that it was bromine or bromine water. Fantastic. Fantastic. That was good. So you remembered that. What about the things that I've just looked at then? What about the hydrogen test? I've done the easiest one just to see if you were awake. What was the test for hydrogen? Good. People were paying attention. Most people were paying attention. Nearly everyone was paying attention. Half of you voted. Come on, let's have some more of you. That'll do. 25 seconds, couple more. Go on, if you're thinking about pressing a button, do it now. Right. Okay. So it was the pop test. Okay, it was the pop test, and the majority of you got that right. You need to know these tests. You have to memorize them. Now, the reason that we've decided to teach these things while you're all at home is this isn't something at all that you, in any shape or form, there's any understanding to this, I'm afraid. This is quite simply, these are things you have to learn. So let's just recap really quickly what I've said you have to learn. So if I just fly through this, you have to know the definition of a pure substance and a fixed point. and a formulation with examples. You need to know that method. You need to know how to calculate an RF value. Here are some for you to try. These aren't getting marked. The answers are afterwards. You need to know the tests for gases. We have gone through all of that so far. Now, I've put this in because I think this is an easy way to learn all of the tests for ions. Now, really, this is something that's very, very practical. This is the sort of thing that's best done in a practical that sometimes takes 2 double lessons. You get lots of substances and you have to work out exactly what they are. So the first thing you do is you test each substance in a flame test to see if you've got any of these positive ions. So if you see what I've done here on this side of the spider diagram, I've got the test for positive ions. There are 2 tests, flame tests and mixing with sodium hydroxide. Okay. In the flame tests, we get these 5 colors. You need to know them. Lithium is crimson. It's a much brighter red than calcium. That's more of a brick red. Okay. Yellow, lilac, purpley color, green. Okay. Good. It's really, really bright green. Okay. Flame tests are great. They're what we do with year 6 when they come up to visit. And they're nice and easy. You use a little loop of wire, you get it in the powder, and you put it in the flame. Sort of question you get asked is sometimes you get false readings, and that's because the person doesn't clean the wire properly in between. If you don't clear the wire properly in between, then you're going to get a reading that's giving you the wrong color. Next thing you do is you put a small amount of the substance in with sodium hydroxide, and a precipitate means you get a solid appearing in the solution. And if you get a solid appearing in the solution, then you are able to tell what it is by looking at this table over here. So you've got white precipitates, you've got 3 things. It could be calcium, magnesium, or aluminium, but aluminium, you can get it to go away again. So you would be able to identify aluminium because you've had more sodium hydroxide, that white precipitate disappears. So that would tell you that you've got aluminium. So far you've been able to identify all of these and aluminium. And then over on the other side, we get colored precipitates. So, and those are down there. Okay. So just knowing those colors is really quite important. And you do actually have to learn those colors, I'm afraid. You have to know those colors. The flame tests, it's really easy. If you do metal flame tests search on YouTube, there are loads and loads, so you can actually see what that color looks like. Look at particularly the difference between crimson and red. I was going to play a video on here, but it's just easier if you just have a look at it. Now, we've got 3 types of negative ion. Okay, we've got the halides, which are chlorine, bromine, and iodine. We don't test for fluorine, so you don't need to know. We've got sulfates, and we've got carbonates. Now, this is nice and easy. The carbonates is the easiest. First, you add some dilute hydrochloric acid, and then we're going back to this test here. You add some dilute hydrochloric acid, you put whatever you're testing in the bottom, and you get a delivery tube, and you bubble it through. If it's a carbonate, you're going to get a positive test for lime water. So that's nice and easy. So we would be able to work out if we did a flame test and it was crimson, and then we did this and we got cloudy lime water, we know we've got lithium carbonate at this point. Okay, but it might be that comes out negative. So we go and try this one. Maybe it's a sulfate. So what we do is we add our hydrochloric acid like we did before, and then we add barium chloride, also colorless, and it goes white. If it goes white, we've got a sulfate. So let's imagine we got copper and it came out green on our flame test. Fantastic. We did carbonates, that was negative. So then we did our sulfate test. We added hydrochloric acid and barium chloride. It went white. We go, right, we've got copper sulfate. We know exactly what we've got at this stage, okay, because we've done our tests. Or maybe neither of these have worked, and so we're going to try this one. So we got a lilac flame when we did our flame test. So we know we've got potassium. We've got a negative for carbonate. We've got a negative for sulfate. We're going to try this one. So this time we had a little bit in a test tube. We had a little bit of nitric acid. We had a little bit of silver nitrate, and it goes white. And that means we know we've got potassium chloride. If it had gone a cream color, and you often need to put these against a white piece of paper to be able to tell which one is which, and it takes practice, we've got bromine, and had it gone yellow, we'd have got iodine. So this is a set of tests. So you need to know, to test for halides, you add nitric acid and silver nitrate, and you look for those colors. To test for sulfates, you add hydrochloric acid, then barium chloride, and you look for it going white. And for a carbonate, you add dilute hydrochloric acid, and then we do our gas test. So if you were told in an exam, a student did a flame test and it went yellow, and then they added hydrochloric acid and barium chloride and it went white, what did they have? And you would need to be able to say, well, they have sodium sulfate, because I know that those are those tests. So that single page there is definitely a giant flashcard for you. Okay, let's move on. Now, some people have said, well, all of that's a little bit too much. I'm a little bit tired of doing all of these flame tests and mixing up all these chemicals. How about just making a machine that does it for me? So I can just pop it in and go, right, there you go. I've got some sodium sulfate. Well, brilliant, because that's much more accurate, because the machine just does all of the testing for me and tells me exactly what it is, and I don't have to be holding up to white pieces of paper and trying to decide if it's white or cream or yellow. It's obviously going to be very quick. I don't have to do all of those tests. I said that takes two double lessons to do every single one of those tests. Even someone who does them all the time, it's going to take a while to get through them. And you only need a tiny drop to go into these instruments. They are very, very, very expensive to buy these instruments. You have to be specially trained to be able to use them. You can't just rock up and turn it on. And sometimes you have to actually have examples of all of the things for the computer to be able to compare it against. So that's a little bit of a problem with instrumental analysis. So what sort of instruments do we mean? Well, the number one is a flame emission spectroscope, flame emission spectroscopy. So the sample gets heated in a really hot flame. And what you already know from knowing about atomic structure is the electrons then jump out into a higher energy level or shell. So they go up from one and they go up one. When they're left to fall back down to the shell that they should be in, that energy comes back out as light. And each ion absorbs and gives out its own pattern of radiation. Okay, so we've got mercury, we've got neon, all sorts of different things. So it can be used to measure the concentration of a sample as well as to how much of that comes out. So we compare those spectroscopes. Okay, so that's the last thing that I'm going to talk about there before we try a little bit of a Kahoot to see what you can remember. So what ones have I not done? Oh, I haven't asked you this. So let's try this. So what color do lithium ions give in a flame test? Now, I know I said this wasn't a memory test. Now, oh, good. People were paying attention. This is excellent. Okay, now this is a subtlety. This is why I want you to go away and look it up on YouTube. Okay, because this is a subtlety. I'm going to give you 5 more seconds. Half of you have voted. The other half of you, go for it. Just go for one. Excellent. End poll. Now, I know I only did that a minute ago, so I don't expect you to remember. Just want to see who was paying attention to crimson. Lithium is crimson. Now, calcium is the other one that is red, and it's more of a brick red. And if you look at a YouTube video, it's really clear. It's a really bright red for lithium. Okay, really, really bright red. And the reason that I've labeled that one is that that's the one where there's another color to confuse it with. We said that in a spectroscope, a flame emission spectroscope, that we move the electrons up an energy level. What do we normally call an energy level when we're talking about electrons in an atom? Fantastic. Not as many people happy about answering this one. I hope you realize I can't see what your answer is. All I can see is how many people gave each answer. I don't know who answered it. So there needs to be no fear of getting it wrong publicly, because I don't know who said it. Okay, unless you tell me that it was you. Okay, fantastic. I'm going to end it there because that's been up a long time. So shells. Okay, so that's what we're talking about, shells. I've got one last question before we do something else. Okay, launch poll. How does chromatography separate mixtures? I did mention this, albeit briefly. Excellent, fantastic, and wonderful. I've got the huge majority of you got this right. It's rocketing up through the right answers. This is much better. I think since I told you I can't see your answers, more people are answering. I'm going to give it another. Let's go for 5 seconds. There's 9 of you to go. Go on. Do it. Do it. Pick one. No. Oh, no, not 9 of you. 13 of you. I can't count. I'm going to end that. there, I share the results. Solubility, good. Chromatography works by separating things by solubility. Right, so I'm going to stop sharing this screen here, and I'm going to share a different screen, and hopefully you've got your phones ready and you are able to, oh, that's not the one, you are able to take part in this now. So this is a little bit about chemical analysis, and we can play this together over Zoom because it works quite nicely, and we can have a little bit of a competition. Please don't use a rude name if you join, because I will automatically kick you out and not wait for you to join. But please do join in, because it lets me know if you understood anything. It's also a little bit of something interactive that we can all do, and it's quite entertaining. I think we've got time to get through the whole thing. There's 40 something of you logged in right now. It'd be great if we could get 30 people playing this at once, and let's make it really competitive. Let me keep a record of who wins, and let's make it for large numbers of achievement points and also for answer streaks. Okay, fantastic. Got 27 of you. I'm going to give it about another minute or so, and then we're going to get started. Wow, what a lot of people. Excellent. Just checking. Wow. Just checking we've not got anything rude written in there. Now, obviously, if you haven't used your actual name and you win, I'm not going to be able to I'm sorry, I'm finding that quite funny. I've just read something. Good. It's not allowing rude names. Excellent. So I am going to start it. 33 people. Any advance on 33 people? Yeah, there is an advance on 33 people. 35. This is going to be the biggest game of Kahoot I've ever played then. And so let's go. You ready? Chemical analysis. Were you paying attention? What was a formulation? If you can remember the definition, you know which one of those things is a formulation. It says you're going to get a minute, but you're not going to get a minute. When this gets up to, gosh, your triples, I reckon I'm going to give you about 20 seconds for each of them. There's 3 people to go. I'm going to call it in 5, 4, 3, 2, 1. Oh, and there we go. There's our scores. Fantastic. I hit next at the same time that it ended there. That was unfortunate. Which method is showing in the diagram? So what is that a picture of? What is that a picture of? Which one of the tests that we have talked about is that a picture of? 2 people to go. Come on. Otherwise I'm going to hit. Fantastic. Majority of you got that. Any change at the top? Yes, there is. There's quite a change at the top there. So a few people moving up. Which one of these is the positive test for oxygen? No, that was one of the 4 gas tests that you absolutely have to know. You have to know these gas tests off the top of your head every single time. Brilliant. 1 more to go. Come on, click it. Fantastic. It will relight a glowing splint. It's quite an impressive thing to see. You get a splint that's lit, and the wooden sticks for lighting Bunsen burners, just in case anyone's not sure. Test tube you think's got oxygen. You blow it out. It's still glowing red. You stick it in, bursts back into flame. It's great. And it's all change again. This could be anyone's at the moment. So this is going quite well. How do we calculate an RF value? Is it the distance traveled? Well, I won't bother telling you. If you aren't sure about this, this is something where you do need to go and practice those examples I gave you. I'm going to click skip. Whoever still needs to go, I'm going to click skip. There we go. Okay. Distance traveled by the dye. Okay, so the short distance traveled by the big distance, the solvent. Okay. Any change? Not quite as big this time. Pure substance is defined as something that has nothing added to it. Is that true or false? Remember I said there is only one acceptable definition. It was surrounded in yellow. It is the only definition that you can ever use. So I'm going to skip that. Okay, it is false. A pure substance is one that contains only one kind of compound or element, not something that hasn't had something added to it. Cannot use that definition. It must be only the definition that I gave you. I was very clear about that. What is the boiling point of pure water? So we use fixed points to try and work out whether something is pure or not. At what temperature would pure water boil? I'm going to skip it if you don't answer. I'm not giving you the whole 40 seconds. It takes way too long. 3, there we go, 100 degrees. Good, I'm glad most of you knew that. Any change? Not really. Right, we're nearly halfway through. Which one of these is a description of a formulation? Gave you this definition partway through. Hopefully you recognize it. Fantastic. Nearly all done. Excellent. Huge number of you knew that. It's a mixture for a particular purpose, like medicines, cleaning products, and paint. Those are the examples you probably need to remember because they really like asking you about formulations in the exam. Each element only emits its own specific spectrum of light once it's been heated up in a spectroscope. Is this true or false? I'm going to give you another 5 seconds. 4, 3, 2, 1. You're quite right. It's true. Every element gives out its absolutely own specific spectrum of light, which means that we can identify it in a spectroscope. And we can also identify what proportion of it is there is. In a flame test, what color does potassium go? Let's see if you can remember. I described it as a different color to this, actually, I've realized, but then I did give this as an example of what that color was. So let's see how many of you can remember. The idea behind this Kahoot is just to bring all these things back into your memory rather than me just waffling about them. Let's see if this really helps you remember some of the things that I talked about. And if you're watching this on catch up, these questions, please be, if you're watching it on catch up, if you're watching it on, sorry, I clicked that. If you're watching this on YouTube, then do watch the Kahoot and shout the answers at the screen as they go past, because this idea of trying to remember them, remember I talk about retrieval practice a lot, this really helps you remember things. Right, what does chlorine gas do out of our 4 gas tests? Okay, I'm going to give you another 5 seconds. We're dropping off numbers here. I think someone's gone to make a cup of tea, and there'll be no prizes for tea. There we go. Bleaches litmus paper white. Good. Lots of people paying lots of attention as we go through. So how far through it? We've got 3 pairs. I've just got an answer streak of 5. We're dead. We're halfway through. We've got to finish this in 5 minutes to finish on time. So sodium hydroxide is added to copper ions. What color did we get? So that was down the bottom hand. Now, you might not remember this, but go for it. Go on. What color did you think copper went when you added sodium hydroxide? So that was down the bottom left-hand side of that spider diagram. Some clever people have probably got the slides open in front of them at the moment and are definitely getting the right answers. It was blue. Okay, it goes copper make green in the flame test and blue with sodium hydroxide. Going very nicely there. This is looking good. Excellent. So which one of the following will dissolve in excess sodium hydroxide? So those 3 down the bottom, we all got white, okay, for all of them, but one of them went away if we added more sodium hydroxide, and that's how we knew it was that one. So that's how we found it. And this is really good that you can remember this. Again, lots of clever people, I think, are have got the slides open at the same time. Excellent stuff. Let's move forwards. Good. Nearly half of you, 1/3 of you knew it was aluminium. So again, I'm not expecting you to know these things. Gosh, Maddie's on a streak there with 6 answers, but this is the act of trying to remember them and then being told the correct answer again is going to help you remember it. You need to go away and make some flashcards. I didn't tell you this. I didn't tell you this. You've got a mobile phase and a stationary phase, but essentially one bit moves and one bit doesn't. And let's skip. Good, the solvent. The solvent's the only thing that moves. That's the mobile phase. Okay, fantastic. A few more to go. in a flame test, what color does sodium ions make? Sodium. Sodium is used in street lights. You'll notice that street lights are this color, unless they're LED lights, because they're called sodium lamps. I just looked out the window though, but they're not on. Let's skip it. 3, 2, 1. Fantastic. Yellow. A few people maybe have got that clue. Street lights have often got a yellow color because they're sodium lamps. What's a benefit for using instruments to analyze the products instead? What's the benefit? Three, 2, 1. 31 people still playing. One more answer. No. Okay. They are very accurate. That's the benefit. Someone missed the question there and said they were more expensive. That's not a benefit. Down to the last 4 questions. What's the more accurate of the flame version of the flame test? Five, 4, 3, 2, 1. Go. It is spectroscopy. Excellent. When testing for halides, we had 2 things. So that was in the top right-hand corner of that diagram. We put 2 things in to try and get, there we've got our white, our cream, and our yellow. That's what they actually look like. There's the results that you'd be expecting. Okay, the white and the cream are quite hard to tell apart. It does take practice. You do need to practice doing it to be able to tell which one's which, and you normally would need a bit of white paper behind you. Fantastic. Nitric acid and silver nitrate. Quite a few of you got that. Ooh, it looks like we've got our winners. Potassium iodide. What color does potassium iodide turn in the test for halides? So really, you're only interested in the iodide bit. What color does iodine go in that test? That's the question. Can you remember? 5, 4, 3, 2, 1. Excellent. Yellow. So if you don't know this, that spider diagram that I gave you, you need to go, and if you're watching this on YouTube, you still need to go away and learn that spider diagram. We're not going over that again. Right. What do we use to test for sulfate ions? 2 things. We put them in. Hopefully you've got it now, because one of those has been used already for a different test. And there are 2 of those that I think look ridiculous. So, because we've not mentioned them. You might notice my camera is wobbling. My laptop is currently, the fans have gone nuts. So I'm holding it off the table and I'm hoping it doesn't shut down before we finish. And I'm going to skip it. There we go. Excellent. Hydrochloric acid and barium. Last question. What's a disadvantage of modern instrumental methods? Look at that. We're going to end dead on time. 5, 4, 3, 2, 1. Right, let's have a podium, because I will give these people plenty of achievement points. We've got Tom. LB, and who's first? Maddie. Excellent. Okay, well, thank you all very much. And we've got Dorothy and Lucas. Okay, that's down there. Now, thank you all very much for taking part in that, because that's really helpful. It's helpful for 2 things. It lets me see how you are doing in terms of your understanding of that, and also it lets you know the things that you need to go back in the slides and learn, because those things aren't understanding, knowing those different gas tests and those flame tests and what emission spectroscopy is. There's nothing to understand there. You just have to go away and learn it. Okay, so it's on the slides, have a read, and then test if you've learned it by trying to answer those questions on the quiz and those 6 markers at the end. Okay, because I think that will be useful for you. I've got a question here. Thank you for the Kahoot. Excellent. I'm going to try and incorporate Kahoots and things like that into everything that we do. I hope you've got plenty to do now. I'm going to stay here. I'm going to stop recording. But if you've got any questions, then I'm going to stay here just for a